In the last lecture module, we put all the pieces on the board for our effective decision procedure. Now all we have to do is assemble them together into a single method, perfect method, such that if we follow it by the letter from beginning to end, it will always give us an answer, and that answer will always be right. So whenever we want to evaluate a direct inference in Boolean logic, we'll draw two diagrams. One diagram for the premise, one diagram for the conclusion. We'll fill them out just as we learned how to do. For the affirmative cases, we'll do the affirmative strategy. For the negative cases, where the premise or the conclusion asserts that the standard form categorical statement is false, we'll do that opposite strategy. Once we've gotten those two diagrams filled out, then we'll look at our conclusion diagram and we'll go, okay, here's how the world has to be in order for this conclusion to be true. And we'll look over at our premise diagram and we'll say, okay, here is how the world is if the premise is true. If the premise is true, does that make the world such that the conclusion also has to be true? Is whatever's in my conclusion also in my premise diagram? If it is, then the argument is valid. Whenever I make the premise true, I also create a condition that would make the conclusion true. If it isn't, then it's possible for the premises to be true without guaranteeing that the conclusion is true, and the argument is invalid. Let's try it out. It's false that no clothes are waterproof, therefore some clothes are not waterproof. So I'll just put this in our standard form categorical statements with letters to represent the individual classes. I'm going to draw out a premise and a conclusion diagram, labeling them as such. Two circles that overlap, one labeled premise, one labeled conclusion. The left-hand circle is always my subject class. The right-hand circle, always my predicate class. Now I'm ready to fill these two diagrams in. Let's start with the conclusion diagram. If you want, you can stop the video now, fill out your diagrams, and start the video up and compare what you did to what I did. Our conclusion diagram says there's at least one thing. It is a C, it is not a W. So I'm going to use an X. I'm going to put that X in area 1. I'm a C, I'm not a W, so I go right there. That's what I need at minimum to guarantee that conclusion is true. What about my premise? Well, first thing I notice is it's got an it's false that clause. I want to remind myself what it would take for the embedded categorical statement to be true. So what do I do when I want to make no C or W true? Well, I would say, okay, look, I don't know if there are any C's and I don't know if there are any W's because I'm being a good Boolean. But what I do know is nothing can be both a C and a W. So that area that's in both circles, that would have to be empty, so I would shade that in. If I want to make that statement false, then I prevent that from happening. I make it impossible for that area to be empty by putting an X in that area, and that is my diagram for it's false that no C or W. Now I look at my conclusion diagram. That's what I need to guarantee my conclusion is true. I need at least one thing that's a C and not a W. Now I go to my premise diagram. What is made true when I make my premise diagram true? Well, there's guaranteed at least one thing that is a C and a W. But there's nothing else in this diagram. That means there's no other commitments that I have to make that premise true. That's all I need. So making that premise true does not give me what I need to make my conclusion true. I need a C in the C and only C area. Do not get one when I make my premise true. So this argument is invalid. I write it out, making sure that Wallace knows I know how to make my diagrams and I know how to read the results off them. Let's try another example. It's not the case that some, and I can't even pronounce this with my dyslexia, but it's a real thing, are not people who fear the number 666. Thus, all of those people are people who fear the number 666. So I'll put that up here in my schematic logical form. I'm going to put a premise diagram and a conclusion diagram out, labeling them as such. Overlapping circles, premise diagram labeled, conclusion diagram labeled. The left-hand circle, always the subject class. The right-hand circle, always the predicate class. Now I'm ready to fill out my diagrams. Now again, you might want to stop the video, try and complete the diagrams and make a judgment about validity, then start the video and compare what you did to what I did. Let's do that conclusion again. All H or F. I'm being a good Boolean, so I say, look, I don't know if there's any H's. I don't know if there's any F's. But what I do know is if all the things that are H's are F's, then there can't be anything that's an H and not an F. That area would have to be empty. So I'm going to shade that area like so. And that's all I need to guarantee all H's or F is true. So that's what I need in my conclusion. What about my premise diagram? Well, again, I've got that it's not the case clause. So I'm going to want to remind myself, what does it take to make some H or not F true? The particular negative. And then I can take that information and use it to fill in the diagram for it's not the case that some H or not F. So if I want to make some H or not F true, there's at least one thing. It's an H. It is not an F. So be in the H circle outside of the F circle. If that's what it takes to make that standard form categorical statement true, and my premise says that it's false, then I make that area empty. Now it's false that some H are not F. So now I've got my premise diagram. I've got my conclusion diagram. I look at my premise diagram and my conclusion diagram. I say, okay, what would I need to make that conclusion true? If I want to guarantee that the conclusion is true, what do I need? I need H and only H to be empty. I look over at my premise diagram and I say, okay, what do I need to make my premise true? Well, I need to make that H and only H area empty. So if my premise is true, I've got everything I need to guarantee that my conclusion is true. The way the world has to be to make my premise true is all I need to guarantee that my conclusion is true. And so I write out valid. Let's go ahead and finish this lecture now by going back and looking at the traditional square of opposition. The modern square of opposition showed us the necessary relationships that have to hold between our standard form categorical statements without that Aristotelian assumption. That is, if we allow our classes to be both empty and to have members, our properties to have instances and to have no instances. What if we just add that Aristotelian assumption? How does that change things? Well, quite a lot. For starters, at least one of our universal statements has to be false. The contrary relationship now holds between our universal statements A and E, so that at least one of them has to be false. And with our particular statements, the subcontrary relationship holds, so that at least one of our particular statements has to be true. Our type I, particular affirmative, or our type O, particular negative, one of them has to be true. And finally, the subalternation relationship holds in different directions. If a universal is true, the corresponding particular is true. My universal affirmative is true, my particular affirmative is true. If my particular statement is false, then my universal statement also false. Falsity rises, truth falls. Same thing on the other side. My universal negative is true, my particular negative has to be true. If my particular negative is false, then my universal negative also must be false. So as you can see, that one little seemingly harmless assumption, the difference between horses and unicorns, that can introduce a whole bunch of extra necessary logical relationships between the individual standard form categorical statements that make up our logic. Now, the practical impact of that is that there will be more arguments that are recognized as valid. So long as that Aristotelian assumption is true, we can use that information and recognize more arguments as valid arguments than the Boolean can. And we'll look at that in the second lecture on categorical logic.